This is your m of t, right? Corresponding Fourier transform is m of f, right? Okay. Now, a question is given that it is something like this was given, right? What is given here is corresponding spectrum. Something like this is given. This is your m of f. Okay, right? And here you have, okay, cos, simply I will write cos 2 pi, okay? I'll give some frequency. Cos 10,000, okay? 10,000. Try to follow this. Pi into t, okay? Cos 10,000 pi into t. Fine. And here you're going to get a double sideband suppressed carrier wave. Yes or no? Right? See, hope you remember, I have done one question. Right? What happens to the spectrum of once you multiply the cos wave? That means once you produce the double sideband suppressed carrier wave, it will go to the passband, I think, right? What is the passband frequency? This frequency, fc. Right? That is, I told you many times, but while solving one problem. Okay. Suppose, see, this is the spectrum. This is m of f. Okay. This is m of f. This frequency is, say, I'll take 2000. This frequency is minus 3000. Okay. This is your m of f. Right? Once you pass it through, once you multiply the carrier signal, right? This spectrum will go to the first band. That means this will go to plus fc. Same thing will go to plus fc. Then it will go to minus fc. This is what I have told you. Go like this. The same thing. This is the same thing. The spectrum at this point is this one. I have done it. Right. I have done this letter. Then in that question, there is one more thing, something like this here. Okay. Okay. What is there in the question? There is one plus mark, one adder is there. Right. And this adder has been given. What is instead of m of t, one m of f is shown. Right. Now see here. What is the spectrum here? Right, spectrum here is this one. Have you understood this? Now onwards, can you don't really mistake. Right. See, you have done the spectrum. See, when your m of t spectrum is like this. What is this now? What is this actually? The spectrum of, what is this now? Tell me. Spectrum of sine wave. Right. Suppose I have a sine wave. It's a what you call it as single tone modulating signal, single tone vector signal, okay, of say 100 Hz. So this will be 100, this will be minus 100. After DSP-SC, what may happen to this? The spectrum of the DSP-SC, right? After some DSP-SC, this will come here, right? This is upper sideband, lower sideband, and same will come here. This is your FC. This is your FC plus FN. This is your FC minus FN. Right. I've understood this. Okay. Now, this is what I have given in the exam. Now, can you tell me what is the spectrum at this point? It's addition, right? Suppose this is frequency, say 2000. This is minus 2000. Can you tell me this is addition of spectrum? So what will come here? It will. This is 2000. This is minus 2000. Right? I understood this. Okay. Now see what happened when this is actually this spectrum is passed through this multiplier with the multiplication of cos 1000 pi t, this has come here and this entire thing has come here. Now suppose, now see here, I'm going to do one more, here I'm going to multiply one more with another cos, okay. Now this is shifting to, this is, now this is shifting to which frequency? This is 2 pi. How much hertz? 500. We will keep some high frequency, right? Okay. Instead of 10,000, I will make it as 4 pi into, okay, 10 to the power of 3. That means 2 kilohertz, right? So this is 2 kilohertz. 2 kilohertz. Okay. Now can you tell me what is this? What is the frequency of this? This frequency. 2 kilohertz plus 2000. It is 4 kilohertz, right? Okay. This one, 2 minus. Of course, if you put according to the scale, okay, this is 2 kilohertz. This is going to overlap with this, of course. I have not drawn it according to the scale, okay. Now, exact scale we will draw, don't worry. Exact scale we will draw. This is 2 kilohertz, okay. If this scale is 2 kilohertz, this is 2 kilohertz, right? Now, of course, when this is shifted to 2 kilohertz here, it will come somewhere here, right? The best thing is that we just increase this to, okay, we just increase this to some 10 to the power of 4, okay, 10 to 16 pi, then 8 kilohertz, right? This is 8 kilohertz. That means this will shift to 8 kilohertz. So I will draw in 8 kilohertz somewhere here. Okay. Now, if you do put a scale 0, okay, 0 here, 1. Okay, sorry for this. 1, 2, 3, 4. Okay. Proper scale will put 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Similarly, minus. I'm not going to draw minus side. You have to do it yourself. Okay. Now, here it is. What is the carrier frequency? FC. FC is 8 kilohertz. Okay. So this will go to 8 kilohertz here. Okay. So 8 kilohertz, 8, 9, 10, 11, and so on. Okay. Now, it will go to 8 kilohertz. It will span 2 kilohertz this side and 2 kilohertz this side. That's okay. This is 8 kilohertz. This entire thing is moving over 8 kilohertz. It's becoming passband. Proof for this also I have given. Right? Proof for this also I have given. Okay. So this is M of t, right? M of t. M of t into cos. You use Euler's formula here, which will become M of f minus fc, f plus fc. You all know that. Okay. Okay. Now, same way, you draw it for minus 8. Okay. Now, this is the spectrum at this point. At this point, what is the spectrum? You just have to 2 kilohertz. 2 kilohertz is coming here. Fine? Like this. Fine. Okay. Now, I will multiply that signal with one more component, one more carrier, because I will make this frequency, this is little bigger. No, no. Whatever you get here, same thing we get here. Right? I didn't get your question. This one. Both will be there. I told you this will go and sit at FC. This will sit at minus FC. I have not drawn it here, but you have to draw that. Right? This will come from Fourier transform. Right? Okay. Moment you take a pass it through this, you will have this. M of t, in the question M of, if it is given M of t, definitely, then you have to find out Fourier transform. That is a big task, right? That type of question might come for company, right? You need to know Fourier transform pairs. Fourier transform pairs you should know. I understood this. Okay, yeah. Okay, so now of course here in -8 this is there. Okay, now tell me, okay, when this is passed through another cos, I'll write cos 40,000 pi into t. Okay, cos 40,000 pi into t. Of course, we need to have enough space. Instead of 40,000, I will take 80,000 means 40 kilohertz. Okay, so you have to put 40 enough, I think, right? 40 enough, no problem. 40 enough. Okay, 40,000 pi into t. Okay, now tell me what is the spectrum at this point? This entire thing will shift by 20,000. Entire thing will shift by minus 20,000. Right? Can you draw it? You have to put proper scale, no? Okay? Proper scale you have to put. 0, 1. I don't have space here. That's why I'm writing here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think you have to have proper span to do that. Okay? See, this entire thing is shifting to 20K. 20K this side. Okay. And entire thing is shifting to 20K this side. That's all. Have understood this. And what is the bandwidth? See the maximum frequency in this. See the minimum frequency in this. Difference between maximum frequency to minimum frequency is going to be your bandwidth. Okay. In this, what is the bandwidth? Tell me. Yes, this entire thing will be shifted to the 20 kilohertz. What is the frequency here? This is 2 pi t, right? 2 pi fct, right? When you write 2 pi fct, this will be equal to 2 into 10,000, 20,000, 2 pi into 20,000 into t. This is your fc, carrier frequency in fc. This center, this zero will be placed on the 20 kilohertz. Yes. Similarly, other side. One head will become two heads like that. Okay. Like, see, this is a spectrum of this is signal. When you multiply the carrying signal of cos 16 pi, what will happen? This will go and sit on the 8 kilohertz. Okay, this side, this will go sit on the 8 kilohertz. So then this will become this frequency, and this will become upper sideband. This will become lower sideband. I understood. It's very easy to remember this step. Okay. What is the, I'll give a small problem now. So those who are in online, you have understood this. Okay. What is how Fourier transform of a rectangular window looks like? Can you draw this?
Sync wave.
Right? Suppose if the input, your M of t is a rectangular window, M of t. Okay? Right. Now, I will write cos, okay, 10,000 pi, cos 10,000 pi into t, right? Now draw the spectrum at this point. What is the spectrum at this point? Can I do this now? Spectrum of rectangular pulse, you must have done it, right? It's a sync pulse. Right, it's a sync pulse. You should remember this thing. Yes or no? Okay. So, yeah, it's just a sync pulse. Sync pulse is, you know, how does it come? Now, can you tell me what is M of F now? What is M of F? M of F is this one, yes or no? This is the M of F.
Yes, a sync function.
Right. Yeah. Then what is your spectrum at this point? Tell me. Can somebody tell me? If you understood, do it. This whatever zero is there, you remove it and put it on the, what is the frequency? 5 kilohertz. Same thing, इसको इधर लेके आओ. Okay. Now this is minus 5 kilohertz. This will go to 5 kilohertz, go to minus 5 kilohertz. This is spectrum. This technique you remember always. Okay. This is called as baseband signal. I told you already. Right. Maybe here frequency is B and frequency is minus B here. This is a baseband signal, band limited to B hertz. Right, to understand this concept. But here, don't worry. I'm not asking anything about but amplitude you have to take consideration. But don't worry about amplitude for time being here. Right? Amplitude, definitely amplitude will be given here. If amplitude is given here, right? Suppose if amplitude is given as say some 4 or 5, that time you may have to consider that. It will decrease because depending on the omega or F here, if it is F, it will be divided by 2. Right? If it is F divided by 2, if it is omega multiplied by 5. Yes. Whatever amplitude is there multiplied by 5. That amplitude will become that is multiplied by 5. That depends on the signal you have. Now, what is this is M of t is equal to 4, right? Now, when you take a Fourier transform of this, what is the magnitude you get? That you have to put it there. Right? This magnitude will be, yes, this magnitude will be, if it is a frequency, it will be half of this. That depends on this. By 2 will come now. Of course, it is by 2 will come now. When you multiply this, yes, it depends on the signal here. It depends on the signal here. If it is once again sine, then sine will come. Right. In this case, cos 10,000 pi t into this only one constant 4 will come here. You integrate, what you will get. Right? Of course. Amplitude will change. Definitely amplitude will change. But that amplitude change depends on the signal here. That you have to solve that problem. You have to see. In this case, M of t is 4, right? M of t is 4, right? In this case, cos 10,000 pi t. Now tell me 4 into cos 10,000 pi into t. Right? And you have to integrate this. for taking the Fourier transform, right? So instead of that, okay, you know that spectrum of that rectangular pulse is this one, right? Once you multiply it with the carrier frequency, it will come here, right? So instead of saying any signal, we take any m of f. Okay, see, instead of taking rectangular pulse here, I will take simply m of t. I will take simply m of t. Okay, I will take simply general case m of t. Okay, I understood this. So why amplitude I am not considering here? Because I am just taking m of t there, right? So at that time, okay, suppose this is your spectrum of m of t, right? This is f, and this is I'll write it as m of f. Spectrum of m of t, band limited. Hope all of you know what is band limiting. Okay, right? That means the maximum frequency in that m of t is going to be b hertz, and this is called as baseband because it's in the low frequency, base frequency, right? Okay. Now once you multiply this signal with the carrier signal, okay, now the same spectrum will be shifted to whatever carrier frequency you have here. This here carrier frequency is, this is supposed to be 2 into 5000 pi t, or 2 pi into 5000 t, 5 kilohertz. So this entire thing will move to 5 kilohertz. I'll draw like this. What will be the frequency of this? Tell me, what is the frequency? 5 kilohertz plus b. 5 kilohertz minus b. Similarly, this side. This is because of Fourier transform symmetricity property. Whatever is there, here will come this side. This will be minus 5 kilohertz, minus 5 kilohertz, minus b, minus 5 kilohertz, plus b. Same thing will come. Euler's formula is going to give the same thing. If this is sine, see how it is going to? Of course. See here, if it is cos, okay, see m of t into cos of, you will take a sine, okay, sine is it 2 pi f pt, okay, we solve this, m of t, okay, into, I'm just asking you to solve in a way using Euler's formula. I'll take sine omega ct. Okay, I don't want to have 2 pi ct and all. How can you write this in Euler's formula? Divided by 2j, right? Okay. Now see here, this will be m of t into e to the power of j omega ct minus divided by 2j. Okay. Now you tell me, I'll take this 1 by 2j outside. Okay. Now m of t e to the power of j omega ct, right? Minus e to the power of minus j omega ct into m of t, right? Now, what is the shifting property here? What is the Fourier transform of this? What is the Fourier transform of this? What is the Fourier transform of this? Suppose spectrum of the m of t is like this. Come on, tell me. Definitely it's shifting, na? This is m of f minus omega c, m of f plus omega c. That means this is shifting to this frequency, this is shifting to this frequency. With the amplitude, something like this. For that, best plan is what you do? No, you make this m of f magnitude. When you say this is magnitude, whatever negative value will become the positive value. always Fourier transform is shown as a magnitude value. I understood this. So then definitely whatever negative is coming here will be shown. This type of problems, these amplitudes are not bothered much. In the question I had given, I was not bothered about amplitude at all there. What I wanted was just the spectrum. One or two people did it, but others, most of them have not done it. It's very simple. See, this will come here, this will come here. This is. Yes. You have done two. Third one is wrong. Yes. 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 Okay. Okay, so I just want to discuss about this. If at all anyone has a problem, still try to correct yourself, because this is going to come for entire communication system. I don't know why you are having trouble with this. This is all signal systems, right? This will come for signal system. This is not never taught in the communication system, right? Okay. So that's why I said these basics are important for this. Okay. Okay.